In this courseware video, we will demonstrate the use of bitmap effect masks. Up until this point, all of the effect masks we have used have been simple shapes, like rectangles, ellipses, or complex shapes, such as polylines using Bezier or B-spline curves. However, it is also possible to use an image as your mask source, taking the alpha, the red, the green, the blue, or the luminance channels as the source of your mask. Then add a loader tool to the composition and browse to the courseware folder. Under Footage, locate the folder named Packs and load the clip you find there. The clip length is 137 frames long, as we can see in the Trim In and Trim Out controls label. Change the global range of your scene to approximately 150 frames. The footage we are loading is 720 by 486, which is NTSC D1. Set your file frame format preferences from the default value to NTSC D1 if it is not already. Click Save to change your frame format preferences. When you view the image, Fusion will automatically view it with the correct pixel aspect. The image we have loaded has an alpha channel. You can see this by selecting the display view and clicking the A button to view the alpha channel. Click the C button to return to viewing the color channel. Apply a color correction to the shot by locating the CC button or color corrector button in the toolbar above the view. Click and drag the toolbar button into the view. This will automatically add a color corrector tool to the composition as well as view it in the large display view. Go to the color correctors controls and adjust the values to change the tint of the image. Push the image towards yellow or towards red. Something obvious so that it's easy to see. Let's create a noise map using one of Fusion's built-in creator tools to moderate the effect of our color correction. Right-click in the flow, select Add Tool, and then select from the Creator tab the Fast Noise tool. View the Fast Noise tool in one of the display views and use Ctrl F to set that display view to fit. Change the detail of the fast noise to give it more detail. Scale in slightly so that you have more little density to the noise mask. And then you can use the seethe control to cause the mask to change over time, or increase the seethe rate to cause it to automatically change from frame to frame. The higher the seethe rate, the more active the mask will be as it moves from frame to frame. Connect the output of the Fast Noise tool to the blue input on the Color Corrector tool. Make sure you don't connect to the green input, as the green input is used for a match reference. We want the blue input for the effect mask. At first, the effect of our mask may not be terrifically obvious. You can still see the red tinting that's been applied to our character. However, if you adjust the seethe, you'll see that tint varies from frame to frame, matching with the variations in the effect mask that we're using. When you apply the output of an image directly to the effect mask input on a color corrector tool, or any tool, then a new control will appear in the Common Controls tab, the one marked with the little nuclear symbol. Select the Common Controls tab, and you'll see an option to choose which channel of the input image is used for the effect mask. The default is almost always the alpha channel, but you can choose red, green, blue, hue, luminance, saturation, or coverage as alternative channels. We'll stick with the alpha channel for this particular example. Connecting the output of an image tool directly to a mask input has its advantage as simplicity. However, you lose control over the mask that you may gain by using an external bitmap mask tool. Disconnect the Fast Noise tool from the color corrector's mask input, right-click, select Add Tool, then choose from the Masks category of tools the bitmap mask tool. Connect the Fast Noise output to the bitmap mask, and then the bitmap mask connects to the color corrector's mask input. At first, this has exactly the same result as connecting directly to the color corrector from the Fast Noise tool. However, if you examine the controls for the bitmap mask, you'll see that there are additional values which may be of use. The first value, Level, allows you to control the intensity of the mask channel. The second control, Soft Edge, allows you to apply a softness to the mask to get rid of additional detail. You can also invert the mask or move it by using the center control to transform the mask slightly in space. As you can see, the Bitmap Mask tool provides additional layers of control over your bitmap masks. Whether you choose to use a bitmap mask is entirely up to you. Delete the bitmap mask tool and the fast noise tool from your flow. This time, we'll use the bitmap mask in a slightly more interesting way. Select Add Tool and choose the bitmap mask tool from the mask category. Connect the output of the PAX loader to the input on the bitmap mask tool and view it in the display view. Then copy and paste a second copy of the tool into the flow. Connect the one bitmap mask to the copied bitmap mask, then take a second output from the loader and connect it to the new bitmap mask tool. View the new bitmap mask tool in the display view, and then set its mode from merge to subtract. Now both bitmap masks are currently using exactly the same image as their source. As a result, we're subtracting the exact same mask and we end up with a black. However, if you now take the center control of the second bitmap mask tool and move it slightly, you can offset the two masks, generating what amounts to a rim mask, or an edge mask, for your object. Connect the output of the second bitmap tool to the mask input on the color corrector, and you can see how that edge mask is now being used to provide directional lighting on our 3D rendered image. Apply a little bit of soft edge to the edges of the mask, and you have a very naturalistic appearing directional light source as a part of your shot. This concludes the bitmap mask courseware video.